All right, this is a review of absolute value equations and inequalities using desmos. So first, on all of these inequalities, anything we have, the first thing we need to do is isolate this guy. It always needs to be an absolute value is equal to something or is greater than or less than something so that we can see what's going on. So first thing we're going to do is subtract that 3 away. We're just removing everything away from the absolute value and working our way in. So we're going to get rid of the 3 by subtracting, and then we'll get rid of the negative by dividing. So now we can divide by -1, and we end up with this. So there is our absolute value. And what we're looking for is when does the absolute value of y equals x minus 5 equal 4. So let's look at Desmos. I've already got this set up. So this is our absolute value right here, and you can see there's our 5 right there. So that is shifted to the right 5 because we had a -5. And then our 2 points of intersection are here, 9, 4, and 1, 4. So this is our y equals 4 line. You can see it's a y equals 4 line. So the solution would be 1 and 9. And if you really look at it now, you can actually see that we are at 5, and how far is it away to 1 point to the left and 1 point to the right? It's 4 units. So whatever number this is, whatever our y equals is, that's how far it is. So if I were to change that to, say, 6, we are now 6 units away left and 6 units away to the right, and that would give us our solution. So when you read these equations, what it's saying is we have a distance, with that capital, from 5 that is 4. So if you're at 5, you're going to go right 4, left 4, which gives us 1 and 9. And that's our solution. X equals 1 and 9. So you can do these by hand as well, but all we're doing is looking for that point of intersection between those two equations, the left and the right. So if I were to change this to a 6, it would be plus 6, right 6. So like this, if we had absolute value of x minus, say, 2 is equal to 10, then we're saying R2 has a distance of 10 to the left and 10 to the right, making this -8 and 12. So our answer for that problem would be -8 and 12. It's the 2 points of intersection. And since we're talking about a y equals x line, basically is what this is. That's a y equals x line, whatever that y value is, that x value is as well. And so you can see that same shape here. We're going 4 to the left and 4 up. So if we were up 5, it would be 5 to the left, up 5. It's a 1-to-1, up 1 over 1. So it's going to give us those points of intersection each time. So whatever number's in here being subtracted, we already know that's how it's going to shift left and right. So if it was a +4, we would be at -4. And if it was a +2, like we just did with a 10, we can see there's our two numbers, 12 and -8. So we had an x minus 2, which is a 2 to the right. And then it's going to be over 12, up 12 to get to the line. So that's 12 units left, 12 units right. It's a -8 and 12. So that's the basic premise behind this whole thing. Let's go back to reset it to 4 and 5. So our solution here was over 4 over 4 from 5. Hopefully you're getting this. All right, let's look at now inequalities. So inequalities, we have to do exactly the same thing. So we'll subtract the 3, subtract the 3. But here we also have to divide by a -1. And if you divide by a negative, that's right, you have to flip the inequality. So this one's the same thing. We're going to do them both at the same time so you can see the inequalities work really well together, whether it's less than or greater than. So we end up with this. So you can see the greater than turned into a less than, but they are the same thing. Together, what they will do is represent the whole thing. So I've used the same numbers we have here. Absolute value of x minus 5 is equal to 4 to show you that same situation. So we already have it plugged in. So if you look at it, the blue is the greater than, and the red is the less than. So here's 4. So these are numbers, if you look at them as I move along, they are greater than 4. So this is when our absolute value is bigger than 4 along these lines in the blue region. And everything in the red line, see the y value here? The y values are less than 4. So our y values are less than 4 until they hit that point of intersection. That's when they become 4, that line, and then it grows from there. So everything below the line is less than. So everything here below the line is when we get less than. And so if you look right here, these are the y values that are less than. So it's between 1 and 9. And then everything above y equals 4, this is the greater region. So you can see these values here are greater than 4. All of these values, we've got a 5, that's a 6, a 7, an 8, a 9. This is the area that is bigger than 4. So that would be from negative infinity to 1 and from 9 to infinity. And that's why when you have greater than, you're getting negative infinity to a number and that number to infinity. And when you're getting less than, you're getting that interval in between. So our graph will always be like this because it's an absolute value. And that will always be that number 5, right? Because that's what it is, 5. And then we have that y equals 4 line right here. So everything here is less than, and everything here is greater than. And so all you need is those 2 points of where it's equal, and we already found those to be 1 and 9. So when the absolute value is greater than, that's the blue, then we get from negative infinity to 1 union 9 to infinity. And I would change this to a bracket if there was an equal sign there, but there isn't, so it's just greater and greater. And so whenever you see greater, that's why we get that or statement, and less than, you get the and statement, because it'll always be less than the line, and it'll be bigger than the line. So over here, this is when our absolute value here is less than, and so we know it's going to be between 1 and 9. And so that is everything for inequalities. For absolute values, you're going to have the equal sign, and it is the two numbers right here and here, 1 and 9. And if it's a greater than when you finish, see our absolute value is bigger than some number, then we know it's the outsides. So it'll be from negative infinity to 1, from 1 to 9, and so on and so on. So you could do these extremely quickly just by noticing if it's greater than, it's here, and if it's less than, it's here. So let's look at some special cases now. So what happens when that k value, so we have y equals x minus 5 for one of our equations, and y equals 0 here, and then over here, the other one is equal to a negative. So what happens when that right side, that k value that we're moving up and down here, is 0 and negative? So let's look at desmos. So we have the x minus 5, that's a shift to the right 5. And so we end up with this. You can see there's my 5, and there's k equals 0. Well, if you notice, it's all blue. Everything is blue here because it's all greater than. The whole thing for an absolute value is absolute values are bigger than 0. It doesn't continue down into the negative region because the absolute values make things positive. So what we have here is an area that's positive, and then 0. So if we follow this down, you can see these are all positive y values. So the x here is 3.02, the y is positive, and then it's 0. And then positive and positive. So we have two situations going on. It's when does it equal 0, and when is it positive? Those are the two situations you have to look at when you do these. So this is all of them. We have greater than or equal to 0. We have greater than 0. We have less than 0, and we have greater than or equal to 0. Then we also have negative and positive. So let's look at when is the absolute value less than or equal to 0. So what this is saying is we have two situations going on. It's the absolute value of x minus 5 is less than 0, and we have the absolute value of x minus 5 is equal to 0. Well, let's look at our desmos graph. So here, everything is greater than 0, so it will never be less than 0. That is completely impossible. There is no less than 0 here. This area is just not possible. But we will have it equal 0. So when does it equal 0? When x is 5. So when we say x is equal to 5 here, we say x is equal to 5. That is the only solution we have. And if we come down here and see when is the absolute value less than 0 only, well, it isn't. There are no values that are less than 0. And that makes sense because absolute values can never be negative. That's what this is saying. This is saying is always negative. And that's not possible. So what we end up with is the empty set, or you can say no solution. It's just not possible. And that'll happen all the time. So if you see an absolute value of anything is less than 0, you say no solution. Well, what about when it's positive? This gets a little tricky, but it's not too bad if you look at the graph. So right here, it's positive. Remember, the big blue and big blue is positive. So what we have is two things going on. When is it positive? And when is it 0? So all we have to do is when you see this situation is it's missing this. It's saying that this, our x minus 5, cannot be 0. That's what it's saying. So it's fine for greater than. And it also cannot be less than, right? So all we want is this as well. Cannot be less than 0. All we're looking for is when is it bigger than 0. And so it's bigger from 0 than from negative infinity to our 5 union 5 to infinity. So you're just listing those two situations. There's our v. It's positive here. It's positive here. And it's 0 at 5. So all we are doing is giving the two intervals of positive for the situation. So anytime you see an absolute value is bigger than 0, you're just omitting that part where it is equal to 0. This is 5 comma 0. This is not good. Not part of inequality. That's it. So we just throw that one away. Now let's put it together. If we had the absolute value of x minus 5 is bigger than 0, then that's everything. Here it's bigger than 0. It equals 0. And then it's bigger than 0 again. So it's saying everything that we have here is a solution. So anytime you see greater than or equal to 0, that is basically the definition of an absolute value. So we would say from negative infinity to positive infinity. And this is all of them. This is our less than or equal to 0. We would only have the equal 0 part that works. You cannot use the negative. Here it's everything is bad. It's the opposite of our definition. And this is everything. And if you have just greater than 0, then it's only this that gets the counting. You don't get to count the 0 part. That one is not included. So only the blue parts. This one, this one, this one, this one should be red because it's everything. Let's just change it because it's bothering me. Change it to red, and there. Nothing works on that one because it's less than 0. And so that's the situation with 0. If it's less than or equal to, you only include the equal. If it's less than, you say no solution. If it's greater than, you include the outer intervals, not the part that is the 5. So if this said x minus 7 is greater than 0, you would just say, okay, from negative infinity to 7 and from 7 to infinity, whatever that part is. So this is all you're looking at is when it is equal to 0. Now, what's the next number? We're going to look at it when it's a negative 4. So let's change our k here to negative 4. Slide it back, and there you go. So what happens when k is equal to a negative 4? You notice everything now turns blue, right? So that means everything above negative 4 is true. But everything below negative 4 is not true. So here, these are not solutions. There's nothing lit up. So if there's nothing lit up, it's not a solution. So we have two situations going on. We have from negative infinity to positive infinity when k is greater than negative 4, and no solution when it's less than. So just think about what this is saying. If it's saying it's less than a negative, that is completely impossible for an absolute value because the absolute value has to always be positive. So there's no way our absolute value will ever be less than a negative. And here it's saying absolute value is bigger than. So that is all real numbers. That is our negative infinity to positive infinity. So anytime you see a negative number, you're getting two solutions. If it's greater than, it's all real numbers, everything. And if it's less than, it's no solution. And that's it. These are all the special cases. So when you're looking at absolute values, you're just looking at those points of intersection and deciding what the answer is.